In the Personal Robotics project, one of the things we're trying to do is make robots that can work with people more effectively. So one of the things that we're looking at to help do that is much better sensing. New sensors helped robotic navigation get much better. In particular, the laser rangefinder allowed things like the Grand Challenge car race and the Urban Challenge to do much better by allowing the cars to sense objects far away. The Perceptive Arm that we're showing has a video camera for long-range sensing, and then it has two kinds of electric field sensing built into the hand. Electric field sensing is a sense that several species of fish use, but people don't use. So the arm identifies the object using vision from far away potentially. Then it uses the first of its electric field sensors to move the hand near the object and track the object as the person moves it around if necessary. And then finally it starts using the electric field sensors in its fingers to pre-shape the hand to the shape of the object and then grasp it.
This is the database of objects that the robot knows about. So when the vision software tells it that it sees chili, for example, it can look in this database and see that chili is classed with the cans and get a couple different parameters for how much force it wants to use to grasp the object, for example. And it also knows what it's going to say when it sees a particular object,
that chili looks tasty.
Different orientations that the object can be in. And each of those orientations has a set of different angles that it's going to use to be able to set that down on the table.
One of the things that we've done with this arm is we've made it behave in a springy fashion, and that has two important benefits. One is that it's safer and more natural for people to interact with it. You know, if you get in the way of the arm, it will just kind of get pushed out of the way by you rather than ramming right through you. The other thing that that improves is when the arm is setting down objects, if it's slightly off about where it thinks the object is, because the arm itself is springy, that's not too much of a problem. If the arm wasn't springy and the robot was slightly off about where it thought the object was, then it might smash the object into the table or into other objects. So the springiness helps both with interacting with people, and it also allows the arm to tolerate more sensing uncertainty. Trying to figure out what it is.
Give me the beer.
Tell that it's beer.
Thanks. This goes in the fridge.
So it's putting it in a different place because it knows that it's a different object.